Hey, Algebra 2, we are starting Chapter 3 today with 3.1, working with polynomials, and we're starting off with standard form. So the standard form of a polynomial is when we go from the biggest exponent on the left all the way to the smallest exponent on the right. So if they give us an original equation of negative 2x plus 4x cubed minus 10 plus 2x squared, we want to put that in the standard form. So what's our biggest exponent? We have the exponents 1, it's imaginary, 3, 0, and 2. So we're going to put 4x cubed first plus 2x squared minus 2x to the first minus 10x to the 0, but you don't see the x to the 0 because anything to the 0 power is just 1. And once we put it in the standard form, the number out in front is going to be our leading coefficient, so that's 4. We represent this by LC, and then the degree of the polynomial right here, that's the highest power, is 3. And then we can take the degree and the leading coefficient, and we can match it up with what the behaviors at the end of the graph should be. So if we have an odd degree and a positive leading coefficient, as the graph goes left, as x goes to negative infinity, the graph is going to go down, the line will go down, so that's y goes to negative infinity as well. And then as we go right, as x goes to infinity, y goes to positive infinity. Little slip up here, wrote the wrong word, so corrected that. So this is even degree and positive leading coefficient, odd degree and negative leading coefficient, even degree and negative leading coefficient. And it really doesn't matter what's kind of going on in the meat of things right in the middle. It could be like a nice up and down, it could be a nice W, could be a quadratic, or it could just be crazy. We don't care what's going on in the middle here. We just care about the behavior at the end of the graph. So here we have an example, y equals 2x to the fourth plus 3x squared minus 10. Our leading coefficient right here, it's 2, so it's a positive number. And then our degree is 4. 4 is an even number. So if we go back here, we see our positive leading coefficient and even degree. So positive leading coefficient, even degree. Both ends, both the left and the right, are going to be facing up. So we say that as x goes to infinity, as we go right, y goes up. As x goes to negative infinity, as we go left, y goes up as well. Two more things here. We're going to get into this a little bit later, but how to graph on Savas. So we have this polynomial. Have no idea what it looks like, right? Our scientific calculator doesn't graph that. We can follow these 7 steps on Savas to graph a polynomial. And then on the graph, whenever the line crosses the x-axis, like here, here, and here, we have x-intercepts. And whenever it crosses the y-axis, we have a y-intercept. I'll try to move it so you can read that right there. We have a y-intercept. And then whenever we have a turning point, right, so we're going up, going up, going up. Now we're going down, 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 right? This is a relative maximum. Same thing down here. We go down, 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 up, up, up. Right here, kind of looks like a vertex. This would be a relative minimum. These are turning points. And then as we can see, we have a positive leading coefficient and an odd exponent. So as x goes to the right, y goes up. And as x goes to the left, y goes down.